number 6. The three circuit elements shown in the figure are part of an electric circuit. The total power absorbed by the three circuit elements in watts is dash. So we have here the circuit given, and you will notice that we have three batteries. Make note of the direction of current and also the polarity of the batteries. Now that is important here. Now the first source, the 100-volt source, you will notice that we have the positive on the left side and the negative on the right. And the flow of current is from positive to negative. While in this case, we have negative to positive. And here, the third source, you will find the negative on top while the positive side at the bottom. Now, if there is a 10 amp of current flowing this way and 8 amps passing through the second source, then how much would pass through this branch over here? Now consider this node. Let's call it node A. Now recall the basic Kirchhoff's current law. What does that statement say? That statement says that the algebraic sum of the incoming currents at a node equals the algebraic sum of the outgoing currents. So in this case, if we consider the node A, the incoming current is 10 amps. So what would be the outgoing currents here? If this is 8 amps, then the rest of it would be passing through this branch here, and that would be 2 amps. Do you see? So that's 10 amps coming in, 8 and 2 going out. So the question here asks about the total power absorbed. Now in order to find out the total power absorbed, we will have to consider a couple of things. One, we find out the power of at each source. So we find out the power at 100-volt source, the power at 80, and the power at 15-volt source. And then we find out what type of power is at each of these sources. So we'll do that step by step. Let's start by finding out the power at each source. Okay? So first, at 100-volt source, what is the power? Let's call that P1. Now the power is, we know that the very basic formula of power, that is the product of voltage and current. So here it would be 100 times the current, 10. So 100 times 10 is 1000 watts. That's the power at the first source. Next, at 80-volt source. At 80-volt source, what is the power? Let's call that P2. That's 80 times 8, 640 watts. And next, at 15-volt source, P3. What is P3? Here we will have to multiply 15 times 2, which is 30 watts. Now here are the three values of the powers. Now the next step is to find out what type of each of these powers denote. Now here we see that the current is passing into the positive polarity of the battery first, right? So that indicates that the power is absorbed. When the current enters the positive terminal of a battery, it indicates that the power is absorbed. Alternately, when the current enters the negative terminal, it means that the power is delivered. So in this case, here it is absorbed, and here it is delivered. And in this case, the power is delivered as well. Now, the total power absorbed, what would that be? Total power absorbed would be the amount 1000 watts minus the sum of the delivered power. So that's 1000 minus 640 plus 30. And the final answer is 330 watts. 1000 minus 640 minus 30 would give us 330 watts. So here, since this is not a multiple choice question, the final answer would be entered as 330. Well, this is the final solution, and I hope it has helped.